Global warming is currently the greatest environmental threat to the world. It endangers our health, jeopardizes our national security, and it threatens our basic human needs. Our personal vehicles are a major cause of global warming. Collectively, cars account for nearly 56% of all CO emissions. With this fact in mind, government policies have an important part in reducing the CO emission. The UK government developed databases listing most of the cars available for sale in the UK. The data contains the latest figures of fuel consumption and emission of new cars sold in the UK. This assignment is to predict CO emission from cars. It is based on the data provided by the Vehicle Certification Agency in the UK. There are 41 car manufacturers with 4,657 samples and 44 features in this dataset. Most of the features in the dataset are based on the European Worldwide Harmonized Light Vehicle Test procedure. Emissions in the dataset including carbon monoxide, THC emissions, nitrogen oxides, particulates and noise. However, our target variable is carbon monoxide emission. 4 prediction models built to predict CO emission: SVM binary classification model, neural network regression, Lasso regression, and Naive Bayes classification model. Some car manufacturers have more samples in the dataset, such as Renault, Toyota, Mercedes-Benz, Land Rover, Ford, and Dacia. According to the WTP test, Fiat, Lotus, and Abarth rank highest of all other vehicles producing CO emission with more than 700 mg per kilometers. Electric cars such as Tesla, Smart, and Seat have nearly zero CO emissions. About 50% of the car models in the dataset are running on petrol. It is obvious that petrol is still the dominant type of fuel. The data analysis of this assignment contains 4 major steps: cleaning the dataset, data exploration, modeling, and lastly, model evaluation. The first model is the SVM binary classification model to predict if the car produces high or low CO emission. The new binary target classes are 0 or 1. Any sample data above the mean of the original target will belong to class 0 and considered as high or bad. On the other hand, those below the mean are 1 and considered as low or good. Grid search CV is used here to search the base parameters for the SVM model. The second prediction model is the neural network using Keras sequential modeling library. The model has 7 hidden layers with mixture of ReLU and leaky ReLU as an activation function, and 1 output layer with a linear activation function. The model is using built-in Atom optimizer and mean square error metrics to measure the losses. The third model is the Naive Bayes classification model. The continuous target CO column is converted into discrete numbers, 0 for low emission and 1 for high emission. A few mixture of Naive Bayes model built. Those are Gaussian Naive Bayes, Categorical Naive Bayes, and Mixed Naive Bayes. 5-fold cross-validation is used to determine the base model. Last model is the Lasso Regression model. First, we investigate the size of each feature weight as a function of alpha. Lasso CV function is used to fit the regression model and find the optimal alpha. In conclusion, the SVM model scores the best between the 2 classification models with 87% accuracy. The neural network regression model performed much better than the Lasso regression and scored 0.13 MSE.